Okay, what we're going to do is we're going to learn how to read the abacus. That's what we're doing. So when we have a number, right, anytime the beads that are touching this horizontal bar, that's what's considered counted. So we have our number, we have our abacus. What is an abacus? An abacus is a counting tool. What it does is it helps you visualize your numbers. So thank you everybody so much for joining. What we're going to do is we're going to read this abacus. So we have 4 over here. We have 4. We have 1, 2, 3, 4. 1, 2, 3, 4. This is actually 40. Why? Because, hello. I love sharks. I love sharks too. So we have 40. 1, 2, 3, 4. 40 on the tens place. That's what 40 looks like. And then we have the ones. So we have 40, right? And then what's our next number? Our next number is actually 9. Well, how do I know this is 9? 9 is actually a value of 5. The top beat is a value of 5, and then we have 4 bottom beats. Hello, everybody. Hello. Good morning. Hello. Hello. Thank you for joining. Good morning, everybody. I'm sure it's morning somewhere. So we have 9 on the abacus. So we have 5 plus 4 is equal to 9. That's what that would look like. I hope that makes more. I hope that's better. I don't know if that's better because I don't know if you could see everything. All right. So thank you so much for liking the live. There we go. So we have 49. That's what this is. We have 49. We have every column is a place value. So if our ones are tens, hundreds, thousands, 10,000. So we have 40. 1, 2, 3, 4. Now notice I do it again. 1, 2, 3, 4. The difference is this side has the top bead. The top bead has a value of 5. Anytime the beads are touching this horizontal bar, this is what's being counted. Thank you so much for liking the live. So when we're looking, we have a 9 here. 9 is 5 plus 4 is 9. This is only 4 because the 5 is not touching this horizontal bar, so that means that it's not being counted. Hello everybody, hello. Thank you so much for joining. We have 0, 0, 0. These are all zeros. Why? Because none of these beads are touching the horizontal bar. The horizontal bar is what tracks the numbers. So this answer is 49. That's what that looks like. And then we're going to get it to this number. Hello, thank you so much for liking the live. So we have our next number. Remember, all the top B is a value of 5. This is 5, but this is actually 50. Oh, thank you so much for the hand heart. Oh, thank you, Yama, so much for the hand heart. I appreciate that. Welcome, everybody. Welcome. Thank you so much. Welcome. So we have 50, right? We have the 5 in this. This is actually 55. But when we add 2 more down here, these are values of 1. This is 1 and 1. So 2 ones is equals to 2. Right? So 5 plus 2 is equal to 7. So we actually have 57. So the answer here is actually 57. We have 5 in the tens column, like that. The 5 in the tens column and the 7 in the ones column. So what we're doing is we're learning how to read the abacus. This is 57. And then we have our next number. Hello, everybody. Hello. Thank you so much for joining. Hi. How's it going? How's it going? So what we're going to do is, oh, thank you so much for the follow, Malik. There we go. So thank you, Peter, for the liking. Okay. So we have our 7, right? The 5 is up here. 5 plus 2 is equal to 7. I want to add 3. 1, 2, 3. So my final answer is 73. That's what that is. So we have 70 and we have 3. Welcome, everybody. Welcome. It is not 64. Right? We're not doing 64. This is actually 73. So our answer goes down here, and then we have our next number. This is easy. For those of you that just joined, or for those of you that's been sitting around for a little bit, what number do you think this is? What number do you think this is? If I have my ones over here, my tens over here, and I just add this, what number? Yes, thank you. Thank you, Aldris. Yes. Easy, right? Simple to use, easy to understand. Thank you so much. Thank you, Yamor. Thank you. So what's our next number? When we are looking at it, what number do you think this is? So we have, thank you, Duncan. So we have this next number. We have our tens and we have our ones. What number? I feel amazing for, oh, good. Oh, good. I'm very happy that you are great at this. Thank you so much for joining and learning. That's the idea, right? I want everybody to learn. Okay, so what's this? It is. You're right. You're absolutely right. It is 20. It is 8. So the top value is 5. The three bottom beads, this is all 1, 1, 1. So together, this is 8, and then this is 20. Thank you. I'm teaching you, am I not? I don't understand those questions. It doesn't make sense to me. But yeah, thank you for joining. Thank you, Doom. Yeah, Doom Lao. So yes, this is 70, 28. 28 takes us all the way over here, and then we're doing this next number. What number do you think this is? Thank you so much. Hello, board. It is 10 o'clock. I don't know how long you'll be staying. I'm a little tired. How about you? So, no, this is not 67. It's not 67. Thank you, Ricky Spot. So our next number is, we have the top bead of value of 5, the bottom bead has 1 and 1. So 1, 1, and then we have 4. 1, 2, 3, 4. Thank you, Dodger. Yes, it is 34. No, it's not 34. It's not 34 because the top bead is not a 3. The top bead is a value of 5, right? So when we're looking, if you want to see 34, 34 would look like this. 3, 3, 3. I'm sorry, 1, 1, 1. This would be 3. But the top bead is a value of 5. That's why it separates. That's what separates the this line separates the top beads from the bottom beads. The top beads is a value of 5. The bottom beads is a value of 1. I'm about to go to sleep, but then I heard. How do you? Oh, bored. That's so funny. Can you give me an example when we might use this in reality? Sure, Dawson. Well, if you have if you teach young children, you have nieces and nephews, you have grandchildren, grandchildren, you can help them learn their numbers. If you wanted to, you can keep your brain active because like we all play with games, video games, any kind of puzzle games, even Sudoku, crossword puzzles, word searches, any of that type, we would use the abacus also as a hobby. The other times we would use an abacus is maybe if you want to be really, really overindulgent, you can use an abacus to keep track of your games. If you like your scoring and stuff, you could use an abacus to do any sort of arithmetic that you need help with. Instead of trying to put it on a piece of paper, you can have it on an abacus. So anytime you do adding, subtracting, multiplying, and dividing, you can do it on the abacus. Is that the reality you're looking for? So yes, it is 74. Thank you, everybody. It is 74. We have 70. We have 5. Did you? I did hear about the red moon. I did hear a little bit about. Is that today or is that tomorrow? So we have the value of 5. We have the value of 2. The value of 1 and value of 1 here. So 1, 1 gives you 2. So 5 plus 2 is equal to 7. And then we have 4. 1, 2, 3, 4. There we go. So our answer is 74. Today at 11:30. Oh, I will be up. I will be up. EJ, EJ, EJ.
Do you understand the words that are coming out of my mouth?
Do you understand the words that are coming out of my mouth?
So our next number is, I don't. Oh, you don't think you're going to make it? You know. So we have our next number. We have our number. Anytime the bees are touching this horizontal bar, right, this is considered counted. We have 1, 1, 1, 1. There's 4 ones here, and then there's 2 ones here. There's 1, 2. So what number is this? What number do we think this is? We have our 10s and we have our 1s. It is not 6. We're not combining the two. We're not combining the two. These are two separate numbers. Just like how we talk about our numbers, we have the 1s over here and the 10s over here. Thank you. Thank you, Dory. Thank you, Board. Thank you, Benji. It is. Yes, thank you, Sanders. It is the answer to the universe. Thank you, Jer Bear. So it is 42. Well done, well done. So we have our next number. And we have this over here. What number do you think that is? This one's easy because it's only one digit. So we have our top bead over here and then the 2 bottom beads. The 2 bottom beads is a value of 1. So there's 2 1s here. And there's a top bead is a value of 5. So when we're looking, thank you. It is 7. Well done, everybody. Well done. Have a good night, board. Thank you so much for dropping by. And I'll see you in my next live. Hope, yeah, go to bed. You know, you need some sleep and you need to keep on a regular schedule. And good luck for tomorrow. Tomorrow will be a fine day. You'll be fine. You'll be fine at school, right? You're doing good at school? So our next number here is the top beat is a value of 5. We have this, right? And we have all the bottom beats, right? What number? See, I told you. You got scared for no reason. It's awesome. I want to see how these works. It is 69. Thank you, Desi. It is 60 and then is 9. 5 plus 4 is 9. Well done, Dory. Well done, Desi. Well done, Benji. So now you guys are actually learning it too. So, oh, sorry. That was wrong. So, next number. We have our 10s and we have our 1s. What number do we think that is? Thank you, Thank you, Dr. Dutch, for the roses. I apologize for not mentioning that. Thank you so much. I do appreciate that. Thank you so much, Dr. Dutch, for 21 roses. Thank you so much. I do appreciate it. Thank you, thank you, thank you. It is 31. Thank you, Benji. Thank you, Desi. 1, 2, 3, 1, right? So we have 30 and we have 1. Thank you, thank you, thank you. Yes, well done, well done. I'm trying to, oh, there it is. So there we are. And so 31 right here, and then we have our next number. That's what it is. What is our next number? That's easy. That's all we're doing. Hello, everybody. Hello. What we're doing is we're doing a 2-digit number. Here we go. Okay. Is it 32? It is 32. Thank you. Thank you, Jeff. Why are the two far beyond? Yes, they are. You're absolutely right. Thank you, Riley. So when we're looking at it, this would be the decimal places. Why? Because there's a dot right here. Do you see that dot? That's my ones place. That ones place helps me to figure out where the ones is, hence the ones place. So because I do that, then I can actually do ones, tens, hundred thousands, 10,000s, and then I have my decimal. The decimal sits between the ones and the tenths, right? The decimal sits right here. It doesn't sit on an actual place value. So we have our tenths and our hundreds. Thank you, Riley. That is exactly what it is. It's the decimals. Thank you. It's about Wick for the heartbeat. Oh, that's not gonna work. I can only do one filter at a time. Sorry. So what is our last number? Thank you so much for checking in. For those of you that are interested, go ahead and check in wherever my forehead is. To get your orange heart me and get your engagement points and so forth, because we want to tell TikTok that you are an engaging person and then you're not a bot. So thank you everybody for joining. Thank you everybody for joining. Thank you for the heart me. It's about Wick. Is it about Wick like John Wick, or is it about Wick like the Witch of the West? Or is it a wick like a candle wick? That's what I wonder. Like that, Riley. So that's what I wonder. Oh, it's John Wick. Oh, I love John Wick. Thank you so much for checking in. Hello, Stacy. Hello, DJ. How are you doing? Welcome back. Welcome. Hello. Hi. I see you, DJ. I love John Wick. So yes, this is 0. That's the answer. The answer to, that's not answer. That's the answer. That's the answer. So what we're doing is we're learning how to read the abacus. Thank you everybody for joining. What we're going to do is we're going to continue on learning how to read the abacus. And then if you notice, we actually have a dot right here. This is my ones place. So if I did this, we can actually read the abacus, because we could put 3,456. That's what that would be, right? And so, thank you so much for the roses, DJs. Thank you so much for the roses. I have 73,000, so it'll be 73,456.25. That's what that would look like. Does that make sense? Let me know if I talk too fast. I know I do. Because I talk too fast, I know I need to slow down. But let me know if I need to slow down or reiterate anything. So, it's about Wick. Did you see John Wick 4? I know it's old, but it was pretty good. I did like John Wick 4. That was really good. So we have our next one. That's our next number. Our next number is 55.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So it's 55,555.55. I watched you on, and my 6-year-old. Oh, that's fantastic. I want my 6-year-old to learn. Oh, that's great. So the blue ones are a value of 5? Yes, the blue ones, all the value of 5. If I did a whole row of 6, this is what the whole row of 6 would look like. If I did a whole row of 8, that's what the whole row of 8 would look like. That'd be 8, 8, 8, 8, 8. But then what if I did 9, right? 9 would look like that.
99 problems, but a ain't one. If you having girl problems, I feel bad for you, son. I got 99 problems, but a ain't one. Hit me.
So this is 99,999.99. See, DJ, I was wondering about your whole sound system because I was trying to figure out how to implement sound system for my lives. Because I really like your sound system, and I was like, oh, that's pretty cool. So that's what this is, 99,999 point, right? Don't forget the decimal, 99. So when we're looking, if we want to do 10, that's what 10 is. This is not 10. This is 55. Because remember, every column is a number. Every number is represented in each column. So this would actually be 55. When we're looking, this would be 10. 10 is a 1 and a 0. So we have 10, 11, 12, 13, 14, and then 15. That's 15, 16, 17, 18, 19, and then 20. There you go. So 20 is a 2 and a 0. So will always be blue? Yes. This will always be, all of this will always be blue. No matter, the top bead will always be blue. Just like on this abacus, this is a 13-column abacus. This is a 7-column abacus. On a 13-column abacus, there's the top bead. The top bead will always have a blue, will always be the value of 5, no matter what. Even on the Chinese abacus, the top bead will always be 5. This line right here is what separates from the top, from the heaven beads and the earth beads, right? So how do you do addition on it? We'll get to that in a little bit. I want to make sure that we understand how to read the abacus, and we're going to go into understanding some of the books that I have for abacus. So we're going to continue on learning how to read. Do you have a, so we have this. Yes, thank you, James. So we have our next number. We're just reiterating how to read the numbers. There's many ways how to read the numbers, but it's exactly the same when it's represented, right? So if I choose this one to be my ones place, or I can choose this one to be my ones place. If I choose this to be my ones place, then I can actually do 0.00001. That's what that would look like. So here would actually be 0, right? Over here would be 1. So that's if I choose this one to be my my ones place. So then if this is still my ones place, I could do Roman numerals. Roman numerals would be 1. That's what 1 looks like. This is 2, 1, 2. This is 3, 1, 2, 3. This is 4, 1, 2, 3, 4. We have 5. That's the value of 5. And then we have 6. 5 plus 1 is 6. And then we have 7. 5 plus 2 is 7. And then we have 8. 5 plus 3 is 8, and then 9. 5 plus 4 is 9, right? 5 plus 4 is 9. Then this is what 10 looks like. It's the same thing if we did the tally marks, right? The tally marks is 1, right? 2, there's 2 tally marks. Here is 3 tally marks, 1, 2, 3 tally marks, and then there's the 4 tally marks, 1, 2, 3, 4. We have 5, the value of 5 right there. This is the 5 with the slash. The 5 will always be the top bead. And then we have 6, the slash and the 5, right? The slash and the 5. So the slash and the 1, that's what that would be. And then we have 7, the slash and 2, the slash and 2 tally marks. Our next one would be 8. The slash, right? The slash right here, and then 3, 1, 2, 3, and then we have 4. The slash, right? That's the slash. This is the 5, and then we have 4 tally marks. 1, 2, 3, 4. So then you might be wondering what 10 is. 10 is like that. 10 is a 1 and a 0, and that's all we're doing. So what we're doing is we're learning how to read the abacus. After we learn how to read the abacus, we'll go into adding, subtracting, depending on time, we'll be multiplying and dividing. But you can do all of it. You can do all the basic arithmetic on the abacus. So this book is available in my TikTok shop. I do have it pinned to the bottom of the screen. When we're looking at it, I do give you instructions on how to read the abacus. Thank you everybody for liking the live. So when we're looking at the, I show you a little review on how the numbers are read. So a 36 would be 3 10s and 6 1s. And then I give you this mask maze. This mask maze, you have the opportunity to download it because I felt like that the paper is a little thin. And so what I did is I actually put it on a thicker piece of paper. And from here, I want to cover the answers because the answers are actually on the path. And so the idea is to kind of make it engaging to understand how to read the abacus. So after we learn how to read the abacus, I give you another way of reading the abacus is where I give you the number, I give you the path. I call this the reverse maze. And what you're supposed to do is you're supposed to color in what the number is. So here's the path, the number 19 here. You're supposed to color in what 19 would look like. right? And then if you're ever curious, I do have the answers in the back of the book. This is only about understanding how to read the abacus in a 2-digit form. I do have a 3-digit and 4-digit maze as well, but that's what this is, right? And so the idea is the first thing we need to do is we need to understand how to read the abacus. After we learn how to read the abacus, we're going to go into how to move the abacus, and that's what we're going to go into right now. Thank you everybody for joining. Thank you so much for joining. Thank you for liking the live, trying to push it out into the FYP. Thank you everybody. I do appreciate it. So the next book I have available is usually for preschoolers. I made it for the preschoolers because I wanted to get the kids young. Thank you so much for liking the live. And so what I'm trying to do is I'm trying to introduce abacus early. Now, it depends on how early you want to introduce abacus. When they start counting, you can introduce abacus then. Why? Because they're already learning how to count. They already are starting to count their cars, they're counting apples, they're counting bricks, they're counting everything. They're counting their steps. So why not add the abacus to it? All this is just a counting tool. And the idea for this is if you start them at counting the numbers, right? Just like we count with bricks, count with pencils, count with everything that they have, all their toys, they're always counting. So even their food, we're counting with their food. Introduce the abacus, because then the relationship between the two is not so difficult. So in this book, what I did was I showed you the example of an abacus. I showed how to read the abacus, and then we start going into activities. The idea for this was that in abacus world, we don't have anything cutesy or anything entertaining about abacus. And so what I'm trying to do is I'm trying to modernize abacus to make it more mainstream. I'm having more activities that is abacus specific, the way the abacus is presented, and all of the questions that are being curated. So we have our numbers. We go from 0 to 9. I only did to 0 to 9 because I wanted to stay within the columns. I didn't want to have to explain within the other columns, but it is what it is. So then we have the counting, and then we have pixel art and so forth. And then after that, we count forward. After counting forwards, we count backwards. So now we're talking about the relationship of the numbers, right? And understanding how the numbers work together. We are talking about what comes in between, and then we figure out what comes surrounding, and then we do comparison. After comparison, we're now going into a little bit of what we call simple addition. Simple addition means what? Simple addition means that they're going to look at the number and they're going to see, is it possible to do it? So Abacus World, for those of you that are interested, Abacus World actually does not focus on the result. We focus on the process. We want to marry the process and divorce the result. Why? Because we all know what the final destination is. I see you more than well, it's the destination. So what is the destination? The destination is that we're all going to die. So that's why you got to make it for what it's worth and enjoy the journey. The journey is to try to figure out how to add and how to subtract. So the question is not positive 1. It is plus 1. So the question is on my abacus. I have 7 first, right? I go to the horizontal bar. I'm adding. Thank you so much for liking the live. If I need to add 1 here, do I have enough to add the 1? Yes, I do. So I add the 1 just like that. I'm going to the horizontal bar, I'm adding the 1. When I want to take away, I just take it away from the horizontal bar. If you know how to add, you know how to subtract. And so we have 2. Notice that 2 is actually just 2 beats. But if I have 7 on the abacus already, when I want to add 2, I just need to add these 2 beats. It doesn't matter which 2 beats, it just matters that I add 2 beats. So I'm going to add 2. When we're looking at it, we're just trying to understand how the beats move. So this is plus 3. You could do the dots, you could do the tally marks. However, I like the abacus way. The abacus way is plus the 5 and the 3. And then my final answer is 8. You can subitize. Subitize means that you can look at a number and you know what it is. So if I was to go to the next one over, I can actually say 50 plus 30 equals 80. We know this. How do we know this? Because every column is a place value. This is the ones, the tens, the hundreds, the thousands, and the 10,000s. You could do the dots, but that's a whole lot of dots. Thank you so much for the follow. Thank you guys so much for the follow. I do appreciate it. So, and thank you so much for sharing my live. I appreciate that too. I'm trying to get it out to the FYP, but we'll see how it goes. So the idea is that we can actually scale it on the Abacus. What does that mean? Well, guess what? What if I wanted to say, I don't know, 500 plus 300? Guess what? I have 800. I know it's 800 because I can see it. This is 8 and I'm at 3 columns over. I know this is the ones, the tens, the hundreds. So this is 800. And that's the greatest thing about the Abacus is that it helps you visualize your number. That's all we're doing is we're visualizing our numbers. We're visualizing our numbers. And so what we're doing, please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
I don't say that this is new because the abacus has been around since Mesopotamia, so it's before what, BCE. Is it right? BCE. 2300 BCE, and then it went to China around 900 CE, and then in the 16th century the Japanese made it more efficient, and that's what we're doing right now. So in the 16th century Japan made it more efficient. We're working with some complementary numbers. That means we're working with numbers that have partners, and how to make a 5 and how to make a 10. That's what we're going to do, and I'll explain to that in a little bit. But what we're doing right now is we're learning how to move the beats. So when we're looking at it, this is some of the concepts that the mainstream math is also teaching as well. But in Abacus world, we actually 27 BC. Oh, thank you, Marmalade. Thank you so much. I appreciate that. So yeah, I didn't take the time to do it. Yeah. So in mainstream math, we talk about making a 10 and making the 5, but they don't use it. Hello, try your best. Welcome. Hello, welcome. Wow, it's like a little reunion. All right, I gotta mark that. I'm gonna make a note of that. Here we go. Where's my little? Nope. Is it this one? Oh, here it is. I see. I kind of put there. Hello. 27. I gotta change this card. BCE. There we go. Yeah. 27 BCE to 23. Okay, cool. Thank you. Hello. Try your best. So, okay. So you might be wondering, well, what are we going to do? We're going to be minusing. This is not negative, right? We're not doing -1. We're doing minusing the 1. So that means that when I have 6 on the abacus, right, I want to take away 1. When I take away 1, all I got to do is just take away 1. I'm moving away from the horizontal bar. So I can't stay. I just want to say hi. Thank you for teaching us about abacus. Good night. Okay, thank you so much. Try your best, and I'll see you in my next live. Thank you so much for joining. Thank you so much for checking in. I do appreciate that. So it is 6. Thank you so much. It is 6. So we have 6 on the abacus. I want to take away 1. Notice when I take away, we're just going, if you know how to add, you know how to subtract, right? So all we do is we got to go with the opposite. That's all we're doing. If we add, we go to the horizontal bar. We subtract, we go down, right? So we go up, we go down. That's all it is. But in mainstream math, there's like a whole these other strategies to do subtraction, a whole different strategies to do addition. But in abacus world, it's the complements of each other, right? If you know how to add, you know how to subtract, and it's very, very easy. Simple to use, easy to understand. So again, this is 2, right? We're doing a -2. -2? No, we're doing a -2. So if I have 7 on the abacus, I want to take away 2. Now, when I take away the 2, all I got to do is take away these 2 beads, and I just take it away. So my final answer is 5. Does that make sense? So what we're doing is we're understanding how to move the beads. Once we understand how to move the beads, we're going to go into doing some what happens when there's not enough beads. But right now, we have enough. So if I have 4 on the abacus, oh, I should do this one instead. So if I have 4 in the abacus like that, and I want to take away, if I have 4 in the abacus like that, and I want to take away 3, all I got to do is take away the 3. And so my final answer is 1. Again, focus on the result, right? Focus on the second number. The second number is what dictates whether or not we can do it, right? The reason why is because it tells us whether or not we need to use a formula. So if it does not need to use a formula, then that's what we call simple abacus. Here we go. So here is 5. When we look at it, we want to do 3 on the abacus, and I want to add the 5. That's all we're doing. We add the 5, take away the 5. Add the 5, take away the 5. See how it's the same? It's the same, but the opposite. So then we do 6, right? We have 6 is 1 bead on top, 1 bead on bottom. That's when we add the 6, right? And so when we're looking, if I have 1 like this, I want to add 6. Again, it's 1 bead on top, 1 bead on bottom, and we add the 6. So my final answer is 7. How do you do multiplication? Very easy. So 7 on the abacus is the same, right? 7 on the abacus is 1 bead on top and 2 beads on the bottom. And so notice it's 1 bead on top, 2 beads on the bottom. But if I already have 2 on the abacus, I need to add 7. So I need to add 7 is 1 bead on top, 2 beads on the bottom. You add the 7. So my final answer is 9. So when we're looking, if we want to subtract 7, we want to push it apart like that. Ooh. Push it apart like that. So we take it apart or we bring it together. That is what 7 looks like. So we could do the same thing with 8. What is 8? 8 is 1 bead on top, 3 beads on the bottom, and you bring it together. That's what 8 is. But if I have 1 on the abacus already, to add the 8, it's 1 bead on top, 3 beads on the bottom, and add it together. So my final answer is 9. Been sleeping, Alex. Are you sleeping with Alex? Or are you sleeping inside Alex? Are you sleeping... I don't get it. So what's our next number? Our next number is 9. When we're looking, 9 is just 9. So we add the 9 or we take away the 9. Add the 9, take away the 9. That's it. So that is this book. Thank you, Cece, for the follow. So I showed you how to add. I showed you how to subtract, right? It's very, very easy. So if I add the 5, I add the 4, right? And I want to take away 8. Take away 8. Well, when we take away the 8, it's minus the 5 and minus 3. So take away 8 is 1 bead on top and 3 beads on the bottom. That's what taking away 8 is. So my final answer is 1. And there we go. So that is a little bit about adding on the abacus. There we go. We're going to get into a point where we need to start learning how to use the formulas. So you might be wondering, well, what about this? This is the strange thing. The strange thing is, in mainstream world, in mainstream school, in public school, they're like, you need to memorize how to make a 9. I'm like, what? Why? So we look at it. This is 1. I want to add the 1. My next question is to add the 8. When you add the 8, can you do it? Yes, you can add the 8. You can do 1 bead on top and 3 beads on the bottom. You can add the 8. There you go. I don't need to memorize how to make a 9. It's the same thing with the 7. So if I have 2 on the abacus, I'm going to add the 7. Look, I have enough to add the 7. So my final answer is 9. We could do it again with the 3, right? 3 plus 6 plus 6. 1 bead on top, 1 bead on bottom, and you bring it together. So my final answer is 9. So we don't need to memorize how to make a 9 because it already does it for us. So there's no point of memorizing that extra bit. And I don't understand when or why. So we have the 4 and we add the 5, and then that's my final answer, 9. There we go. Right? Right, Rockwell? It's so easy. Simple to use and easy to understand. Thank you so much. Yes, I do appreciate that compliment. It's crazy, right? It's crazy. It's super simple. Who would have thunk it? Who would have? Somebody said, yeah, abacus is common core, but it's not common. Thank you, everybody, for joining. Thank you, everybody, for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Welcome, 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 everybody. Welcome so much. I do appreciate you being here and just taking your time to understand how to use the abacus. So we learned how to read the abacus. After we learn how to read abacus, we're going to get into understanding how to happy ride, happy life. We're not there yet. You want to do that now? No, let's do this first. So the idea is we're going to be adding a 5 first. Happy ride, happy life. Can we put a pin in that? And then we can go into something... Let's put a pin in that. Yeah? So then what we're going to do is we're going to learn concept first. The concept is going to be super simple, but it's very different than what mainstream math is, just so you know. The reason why is because there's going to be stages of learning math. And so that's the one thing about mainstream math is that they don't break it up into they kind of break it up in different stages, but it makes more sense to break abacus up into a different stage. So that 8 plus 2 is at a different stage. The first thing I want to do is I want to show you how to add when there's not enough. Thank you so much for liking the live. Thank you, everybody. So the first concept we're going to do is understanding what 4 plus 4 is. Now, instead of memorizing what 4 plus 4 is, and instead of counting up, we're not going to be counting up. What we're going to be doing is we're going to be utilizing this concept of how to make a 5. Here is a question. Do we all know how to make a 5? We know how to make a 5. 4 plus 1 is equal to 5. Or you could do 1 plus 4 is equal to 5. You could do 3 plus 2 or 2 plus 3. That doesn't matter, right? As long as you know how to make a 5. So these are the pairs that you need to know. There's a whole set. This whole set tells me that I can make a 5. When does this happen? Well, this is going to be leveling up. This is going to level up the idea, the concept of making a 5.
Level up, 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 level up.
Okay, so the first thing I want to do is there'll be a few different ways that I'm going to explain how this works. So the first way I'm going to do is with my pennies and my nickels. Sometimes people understand it this way. So I have 4 on the abacus, right? I have 4. That's what 4 is, right? Easy. Not a problem. I have 4 in the abacus. I have 4 pennies. 1, 2, 3, 4. So now I got to add another 4. To add another 4, what do I do? Well, I cannot do this because this would be 44, right? So because this is 44, that's not the correct answer. What we got to do is we got to remember that what we're trying to do is we're going to try to add 4 to the ones place. So that means we got to do the ones place. That means I got to do this. I have to add 4 to here. There's not enough beads to add 4, just so you know. So what are we going to do? Well, this is where we have to make a 5. I have this nickel. This nickel is more than enough to give you 4, but it's too much. Because I can't break this nickel, I got to do an exchange. If I give you the 4, I got to get an exchange for the 1. So I take away the 1, and there we go. So my final answer is 8. 5, 6, 7, 8. I can do it again on the abacus. I can add the 5, take away the 1, and my final answer is 8. Okay, so that's one way. Here is another way of looking at it. I have 4 beads on the abacus, just like this, right? If I have 4 cubes, I have 4 beads, right? Who is my target audience? Anybody who likes puzzles. So then we have another one. We have these 4 like that, right? My target audience are also parents. They can be adults that are interested in puzzles. They're people that are interested in learning new things. Other target audience could be people that are teachers teaching special education children, teachers who want to provide enrichment programs for students that, to challenge them. Other target audience would be parents with kids, either young or old. It all just depends on their learning skill and learning style. People who have disabilities, maybe some dyslexia, dysgraphia, maybe dyslexic, did I say that? And dysgraphia, I said that already. Dyscalculia, I think is what I meant to say. Sometimes some of the parents can see a benefit of using this when they if the kids have ADHD. Sometimes the benefit of learning the abacus, or my target audience would be those parents that want their kids to be a little bit more academic and not worrying about math. Some of the target audience could be, let's see, getting the kids just comfortable with it, or even if they wanted to get their kids into math competition. Oh, there you go. Homeschooling. Yes. Thank you, Jess. Thank you, Jess. Yes. People who want to learn. Yes. That's a very, very broad subject right there. Target audience. So if you don't like it, then you can leave. I don't know what's going on, but I'm trying to provide knowledge, and I do have adult basic math for adults. Is that a triggered question? I don't think that's a triggered question. It's just so exhausting to explain what my target audience would be. You know what I mean? So thank you for the dolphin. Thank you for the dolphin. I hope my sharks don't eat your dolphin though. I don't want the sharks. I gotta hold the sharks back. Thank you. Right. Thank you, Ryder. Right, Ryder. I think that's what it is. Thank you for the rose. Oh, I can't do that. Thank you for the rose. Okay, so thank you, Tanya, for sharing my live. I do appreciate it. I do appreciate everybody following and understanding. Ah, thank you. Oh, good. It is writer. Okay, good. It just doesn't. It's anyways. Thank you. So I'm going to continue on. I have 4 on the abacus. 1, 2, 3, 4. I have 4 on the abacus. I have 4 right here. Well, guess what? I don't have enough room to add this extra 4. That's what this is. Because I have no room to add the extra 4, guess what I'm going to do? I need to make this and round it to 5, right? Why? Because I can utilize this 5. But to do that, I got to add 1. The 1 has to come from somewhere to make a 5. Guess what? It's going to come from the previous number. So if I take away the 1 from the previous number, like that, and then I add it to my bottom number, like that, then this becomes 5. So all I got to do is add my 5 and take away the 1. So my final answer is 8. 5, 6, 7, 8. So it's just like learning, it's just like drifting. You have to go left to go right.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
So just as what we did is we had to subtract in order to add. Thank you, Nazar. Thank you so much for checking in. Thank you, everybody, for checking in. For those of you that are interested, go ahead and check in the Orange Heart Me and get your engagement points. Every time you make a comment, you get points for that too. So yeah. So that's what this is. We could do it again with the 3. If I have 3 on the abacus, I want to add 4. When I add 4, it's the same thing. We got to make this into a 5. To make this bottom one into a 5, why? So we can utilize this top bead. So we have 3 on the abacus. What do? To add the 4, right, to make it a 5, I need 1. 1 has to come from somewhere. 1 comes from the previous number. 1 comes from the 3. You take away the 1 from there, you add it to the 4, and now I have made a 5. So my final answer is 7. We could do it again with the 2. The 2 on the abacus, like that. 2 on the abacus. And I have 4. Because I have 4, I can make this a 5. To make this a 5, I need to add 1. To add 1, I need to get the 1 from somewhere. To get the 1, I get it from the 2. So I take away 2. I take away 1. I take away 1. And then I add the 5. And it makes a 5. And there you go. Thank you, TikTok. Thank you for the share. So what we're doing is we're understanding how to utilize the 5. How are we doing? Does that make sense? Thank you, Gala, for the follow. So we can do it again. Guess what? Trying to... Thank you, Jess, supporters of trying to get her to take over the world.
Gee, mate, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
Why do you start? Thank you, Ducky, for that question. Thank you so much. I do appreciate that one. That's because I have a dot right here. This dot tells me it's my ones place, and when I put it down and I line it up, this will be my tenths, this will be my hundreds. Does that make sense? So that's why I start there, because I have an indicator, a label. If I really wanted to, I could use this one right here. I could use this one and I just move it all over. So then I just be here. But the problem is if I do this one right here, then I have no room for the hundreds. So I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10, 20, 30, 40, 50, 60, 70, 80, 90, and then I'm stuck. I have no room for 100. Yeah, but thank you. That's a really good question. I do appreciate that. Okay, so we're going to continue on. Why? Because there's a whole set. So what I'm doing is I'm trying to show you that it becomes scalable. Right? So, so we have our question. Here is our question. Oh, we gotta do one more. Okay, we did one more. Here we go. So here is another question. We got to understand how to make it. We have four in the abacus. Oh, I can't see that. We have 4 in the abacus, right? We have 4 in the abacus, right? We have 1, 2, 3, 4. We have 4 in the abacus. We want to add another 3. We want to add 3. But guess what? Excuse me. There's no room to add 3 here. Because there's no room to add 3, what are we going to do? We have to make a 5. To make a 5, what do? We have to add 2. To add the 2 has to come from somewhere. It doesn't come from the ether. It's got to come from somewhere. Guess what? It comes from the previous number. The previous number is what we're going to use. So what we're doing is we're going to regroup, take that away, take it away from the 4, and add it to the 3. So now I have made a 5. My final answer is 7. Now it's easier to see. Add the 5. So my final answer is 7. Easier to see, right? 5 plus 2 is 7. 5 plus 2 is 7. We could do it again with a 3. So we have 3 on the abacus. There we go. Then we have 3 on the abacus, like that. I want to add 3. Guess what? To add the 3, there's no more room. But what do? Because we are a little bit restricted with the abacus, we know that we need to add 2, right? We need to add 2 to this 3, to the bottom 3. It's always the bottom number that we're using, right? It's always the bottom number that we're trying to make a 5. So when we're looking, I want to take away 2 from the first 3. I take it away from the first 3 and I add it to here. Hello, Danny. And then I've given then I made a 5. Because I made a 5, I'm like 5 and then 6. So my final answer is 6, and we could do it again. So then we could do it. Oh, so now I can show you how it scales. So we have this one right here. Hello, J-Med. Hello, Jay. We're not there yet. I don't even know if I'm going to have time. It's been a long day. So we have this one. We have 1, we have 3, 5, and 7. 7. So 1,357. And then what we're going to do is we're going to add 4,433. Well, do we have enough to add the 4? No, but we remember how to add the 4. To add the 4, what did we have to do? All we had to do was plus the 5 minus the 1. That's what we had to do, right? To plus the 4, we had to plus the 5 minus 1. So plus the 5 minus the 1. And then we did it again. I won't be staying long too, but I wanted to chime in and say, oh, thank you so much, Jess. Thank you so much. Okay, Marmalade. Have a good night. Hello, Danny. Hello, Jay. Yeah, I don't think we're going to do division tonight. But I do appreciate you coming by. So the next one is I want to add the 3. Remember how to add the 3? We know when we want to add the 3, it is plus the 5 minus the 2. So we're going to plus the 5, take away that 2. So my final answer is 6. So we have 5,600, and then we got to figure out this 3. Is there enough to add the 3? Yes, there is. So it's 1, 2, 3. And then we add the 1. Is there enough? Yes, add the 1. Okay, Jess, have a good night. Thank you, Alan. Thank you, Alan. Have a good night, everybody. So this is what our number. So our final answer is 5,688. How are we doing? Does that make sense? So what I just did is I showed you how it's scalable. As long as you understand the concepts, then it's easy to scale the numbers. It doesn't matter it doesn't matter which column you're in, just as long as you know what you're trying to do. Again, what we're doing is the second number. Where is it? It's always about the second number. I got you. Yeah, I know, that's crazy. 10K in less than 10 minutes, that's crazy. So when we look at the second digit, like that. Thank you so much, Jess. Okay, are we teaching long addition? No, we are not teaching long addition. We are teaching efficient addition because it becomes scalable, right? Crazy. It's so crazy. As long as you understand these concepts, it doesn't matter. It doesn't matter. You can put it anywhere in the columns. It's all the same. Whereas in mainstream math, they'd say like, oh, why don't you round this number to a friendly number like 4,430, and then you would have to remember that you took away a one, so then you have to add that one to the 13,058, and it gets kind of crazy. It gets a little crazy. But in Abacus world, we don't look at it as a whole. What we do is we look at it the individual numbers, because really that's what you do anyways. So if you really noticed it, right? If you really notice it, right, we're looking at one number at a time anyways. I don't know why mainstream math does the number like a number as a whole. As a preschooler, this is very helpful. That's very impressive, Christian, that you have such a vocabulary to be able to write that. Well done, Christian. You must be reading novels for your reading class. I don't think you take naps because you're pretty academic. You're pretty academic for being as well off. So, okay. So now we're going to get to how to make a 10. That was the one question. The one question was, well, what about adding a 10? Well, here we go. I love it. I love it. You know why? Because it keeps me on my toes, right? It keeps me on my toes. If I just did this, it would be boring. All right. So the next one we're going to do is how to make a 10. That was one of the questions, right? One of the questions was how to make a 10. You guys. Jess, you're so easily amused. All right. So what we're going to do is we're going to understand how to make a 10. Remember that these are pairs. Because we know how to make a 5, now what we're going to do is we're going to compound our information. We're compounding our information. We know how to make a 10. We know how to make a 5. It's the same concept. We know how to make a 10. Now we're going to utilize it. That's the difference. In mainstream, we don't utilize it. In mainstream, they don't utilize how to make a 5 or how to make a 10. But in Abacus, we do. That's why if you ever see those kids do this, it's because they're doing the Abacus. I laugh so loud. My cat gave me a dirtiest look. You scared your cat. That's hilarious. Thank you, Christian, for the rose. You're quite academic. You're quite. Duh. I wondered what those finger moves. Yeah. So if you think about it, when I did this, right, and I do this, that's what they're doing. But they're doing this, right? And so that's what they're doing, and they're doing it fast, right? I'm going a little bit slow, but they're doing it fast. And so when we do this, right, that's what they're doing. We do this, right? Yeah. Kurt is a rich preschooler where he gets Rose's phone. Daddy. I hope Christian has a sense of humor. Okay, so we're going to go back. To make it 10, these are the pairs. 5 plus 5 is a pair, right? 2 plus 8, 7 plus 3, 4 plus 6, 1 plus 9. These are all the pairs. So what happens is, let's say that one question was 2 plus 8. Well, we know, let's do 9 plus 9, let's do 9 plus 8. The reason why is because I can show you and you can see the thing. So it's the same thing. What we're going to do is we're going to have 9 on the abacus. I'm going to use my blocks again. So I have 9 on the abacus, right? We do 9, right? And what are we going to do? Well, we're going to add 8, but there's not enough room to add 8 on this column. We have no room to add this 8, right? What we're trying to do is we're trying to add a 9. On the 9 of the abacus, we're trying to add 8. There's no more room to add the 8, so we have to make a 10. this is what mainstream calls carrying over. But in Abacus, we call it making a 10. We take away the 2 from we take away 2 from the 9, right? Why? Because we know how to make a 10 with an 8. 8 plus 2 is equal to 10. Guess what? If I do that, I have now made a 10. If I take 2 away from my 9, I have made a 10 with my 8. All I got to do is show it. So my final answer is 17. What are we doing? What we're doing is we're regrouping. This is the concept of Abacus of regrouping. We take with what we have and then we regroup. The things that when mainstream math does it, I don't know where they're getting their numbers from, but in Abacus world, we get them from the previous number. So it's not a long addition, it's more efficient because we know these concepts. And because we know this, we don't need to memorize the math facts of 9. So I'll continue on. So the one question was, how do you add 2 and 8? Same thing. If I have 2 on the abacus, I want to add 8, there's not enough. So what happens? You have to minus the 2, take away the 2. Why? Because you want to use this 2 to make your 10 with the 8. So I've made a 10. Does that make sense? I understand the formulas, and doing the problems are fun. Yeah, doing the problems are fun. Doing the problems are fun when you know your formulas. And what we're doing is, what I'm teaching you right now are the formulas. It feels like a puzzle. It does feel like a puzzle. And that's what one of the things is, what I've noticed is anybody who likes puzzles will really enjoy Abacus. Whoever likes puzzles will really enjoy learning math through Abacus. Because Abacus gives you the foundations, Abacus gives you the elements, and then it's up to you to figure out how to get there. Yes, it is up to you how to get there. You can get there in many, many different ways. You can get there, hello, Robert! Hello, Robert. How you doing? Yeah, so you can go in many different ways, but the biggest thing is understanding your 2 formulas. And there's no one right way. You can get there in any way possible. It's just there's the efficiency behind the Japanese abacus method of arithmetic. Hello, Jay. How's it going? How's it going? So we could do it again. I just finished my live. Oh, that's fantastic. That's fantastic. I'm about to crash, actually. Okay. I'm so confused. Oh, L, not a problem. You just joined. Okay. So here's a question. Let's do a little review. How to read the abacus, because that's the first thing that we need to do. We need to understand how to read the abacus. Thank you so much, Elle, for letting me know. So this is the value of 1. The 1 bead right here. So just like I have 1, this is 1. Does that make sense? Let me know when I don't make sense, or let me know if everything makes sense. So I have 1, 2, 3, 4, right? This is 4. Every time the beads are touching this horizontal bar, they're being counted. So right now we have these values, 1, 1, 1, 1. There's 4 ones right here. This is 4. Now the next thing we're going to do is we're going to understand that if I take this away, this will be 5. That's what 5 is. Okay, Daddy, go to bed. Oh, buenas roches. That's funny. I'll see you in my next live. So this is 4, right? That's what 4 looks like. If I want to add the 5 will look like this. 5 is always going to be the topic. See you in my next live. Bye. See you later, Marmalade. Are you leaving too? So we have 5 on the abacus, and then we have 1. 5 plus 1 is 6. 5 plus 1 is 6. And then we have 7. 5 plus 2 is 7. 5 plus 2 is 7. And then we have 8. Is this making sense, Elle? And then we have 5 plus 3 is 8. 5 plus 3 is 8. And then 4. 5 plus 4 is 9. Is that making sense? So then you might be wondering what 10 is. 10 is that. That's what 10 is. 10 is a 1 and a 0. Aw, thank you, Jess, so much for the roses. I don't know if he heard. That's okay. I do appreciate all the gifts. So the blue is the extra number. No. The blue is not an extra number. The blue is that. That would be making it 6. Oh, you're here. Oh, yeah. Marmalade went to, thank you, thank you, thank you. Marmalade went to sleep. Oh, it was Marmalade that went to sleep. Oh, I thought you were leaving too. Does that make sense? Yeah. So this becomes 60. 60, right? 60. So when we're looking, it's a 6 and a 0. 60. Because every column is a place value, like this. So we have our ones. I'm sorry, I can't see that. We have our ones, our tens, hundreds, thousands, and 10,000s. I'll be leaving soon. Okay. Okay, Jess. See you later. Eyebrow. Do you have a skincare routine? I try. I'm making so much art. That's fantastic! Oh, that's so exciting that you're making so much art. That's exciting. That's exciting. You know, and that's what it's all about, to being your side quests, to make sure you continue on being creative. Yeah, does that make sense, Elle? So when we're looking, this would be 64, right? Because this is our ones, this is our six. I don't know if I told you. Yes, that's, October 4th. I didn't know when. I knew you were doing an art show, but I didn't know when. October 4th. Can you only do addition? You can do adding, subtracting, multiplying, and dividing. But I don't think we're going to get into any multiplying or dividing right now. We're just going to go into adding, and I think I'm going to crash. Okay, how are we doing? Yeah. Yeah. So right now I'm showing you the basics. I'm showing you the fundamentals of understanding how to move the beads and how it relates to numbers. So that's what this is. So that's why I had my little bricks and my little boxes. So I had 9 on the abacus, and what we're doing is, there we go. We have 9 on the abacus, and I want to add 7. When I add the 7, right, we know what? What do we know about the 7? We know, I'm going to divide my wings. When we want to add 7, we know we want to add 7. Here's 7, right? 5, 6, 7. We want to add 7 to this 9. We want to add 7 to this 9. Why? Because, thank you, Eyebrow. Thank you so much for the goat. Because we want to add 7 to the ones place. We do not want to add 7 to the tens place because this is 70. This would be 79. We don't want to add 79. We want to add 7 to the ones place. To add 7 to the ones place, what do we know? We know how to make a 10, right? Thank you so much. Let's get to 20,000. Oh my God, that'd be crazy. That'd be crazy. That'd be awesome. Yeah, I'm just looking at my stats. Okay. Okay, thank you. Okay, sorry. So we're back. 9, right? 9 and 7. To make a 7, what we always do is we always look at the bottom number, and the bottom number is what we're going to round to 10. To round to 10, how do you do it? You got to go to a 10, right? So how do we make a 10 out of the 7? To make a 10 out of the 7, you got to add 3. Where does the 3 come from? The 3 comes from the 9. So you take away 3 from here. You take away 3 from here, and then you can regroup to make a 10. You regroup to make a 10. So my final answer is 16. So what we just did is we did a carryover. We just did a carryover. That's what we did. We carried over to make a 10. And it's different than memorizing your doubles and doubles plus 1 and doubles minus 1. What we're doing is we're understanding the concepts of how to make a 10. And how to make a 10 is what we always teach, is what we're teaching the kids now. But we don't utilize it, right? So, but this is working with itself. You take from what you have. You don't take from the ether, right? The numbers are not created. And so anyways, we're going to keep going. So now, if you understand how to add, you know how to subtract. We're going to continue on. We can do 4. And again, the question is, if I have 8 on the abacus, there we go. If I have 8 on the abacus, guess what? I'm not going to try to make 10 out of this 8. Why? Although it's closest to the 2 to the 10, although it's closest to the 10, the question is where are you going to get the number from? Where are you going to get 2 from? That's not how it works on Abacus World. What works on Abacus World is if I have 4 on the abacus, I want to make the 4 a 10. The reason why is because you take from the previous number. 4 plus 6 is equal to 10. So all I got to do is take away 6 from the 8 and gives me 10. So I take 6 away from the 8 to give me a 10. So my final answer is 12. Did that make sense? I hear a lot of thinking. How are we doing? Make sense? Okay, good. Again? Okay, let's do it again. Hello, Reaper. So, the question is what? The statement is, I am not going to make the 10 out of this 8 because I don't know where the 2 is going to come from. So what's going to happen is, I have my next number. My next number is 4. How do I make a 10 with a 4, right? We want to do 4 plus 6. 6. Look at that. If I add a 6, I can make a 10. So if I add a 6, I have to get the 6 from somewhere. So the 6 comes from the previous number. It comes from the 8. So if I take 6 away from the 8, right? Take 6 away from the 8, I can add it to my 4 to make a 10. And I just did a carryover. I just carried over. And my final answer is 12. Let's do another one. Let's do 7. Let's do 7, right? It's the same thing. So we have 7 on the abacus. I have 7 on my abacus, right? I want to add 4. 1, 2, 3, 4. There's no more room to add 4. There's only 2. Because there's no more room to add 4, I know my next 2, I need to round up. To round up to 10, what am I going to do? I'm going to use a 6. So I'm going to round this up to 10. To do that, I need to take away 6. But 6 has to come from somewhere. 6 needs to come from the 7. So we're using what we have. I take away 6 from the 7, and I add it to the 4. So my final answer is 11. And I add the 1. I add the 10. And so my final answer is 11. We can do it again. We could do it again. Let's do 8. We have 8 on the abacus, right? This is why it's good that you know your formulas. It's good that you know the partners. How do you make a 10 out of a 3? 10 out of a 3 is 7. So we have 8 on the abacus, right? We have 8 on the abacus. Let me do that again. 1, 2, 3, right? There's 5, 6, 7, right? 8. I have 3. Notice I have no more room to add 3 on this column. Because I have no more room to add 3 on this column, guess what I'm going to do? I need to make a what? I need to make a 7. To make a 7, where am I going to get it from? I get it from the previous number. You work with what you have. I take 2 and 5 away. And I take away 7 from the 8. Now I can add it to my 3 and I've made a 10. So what I just did was I carried over. So my final answer is 11. There we go. So which one are we doing? We are doing this one. Plus 10s. That's what we're doing. We're doing plus 10s right now. There we go. Thank you, Ducky, for the follow. I get it, right? It's easy. Once you get it, you can never unsee it. Oh, where is it? This is for L. L.
Oh, I can see everything.
Right? Because you can see it. It's the same thing with the 5s. Okay. You know how to add. We're going to do subtraction now. Because there's this one concept I want to show you. We're going to subtract. Why is the column the first digit? Why do you use that? Oh, the reason why is because I have a label. That's all. I have a label right here. Thank you, Jason, for the question. The label is right here. This label tells me it's my ones place. That's all. And so if I do that, then when I put my labels down, I have my ones, tens, hundred, thousands, 10,000s. This right here is my label for my comma for my thousands. So then I have my decimal, and this would be my decimals. This would be tenths, and this would be hundreds. Okay, so now we know how to add, we know how to subtract. What does that mean? Same thing. Let's do it the backwards way. So we know 9 and 10. 9, 10, and 1. So what's going to happen is if I have 11 on the abacus, I need to take away 9. To take away the 9, there's no more room to take away the 9. I got to break this, right? I got to take away the 10 and add the 1. Hello, Alex. I just got here. Nothing about this math tool. Oh, and know nothing about this math tool. Okay, hold on for a little bit. Hold on for a little bit. Let me go through this concept. So wait, the hundreds, the thousands look alike. Yes, exactly. It just depends on which column you're in. So we have the hundreds, we have the thousands. So we have 9 and 9. We can do 3 and 3, right? They look exactly the same except for where the column is. So if I did this would be 1. This would be 3. So it would be 3,303. Each number is represented in each column. So we have our ones, our tens, our hundreds, our thousands, and our 10,000s. Hello, 300. Thank you, Emma, for checking in. Thank you, 300. Thank you, Jess. Yeah. Oh, okay, good. Yeah, it's super simple. It's super simple. Just sit back a little bit and you're going to start seeing it. You're going to start seeing the number patterns. But I'm going to continue on, yeah? Okay, so we're going to continue on and understand. Ellie, does that make sense? When we take away the 9, we want to take away the 10 minus the 1, right? Minus the 10 plus the 1. Does that make sense? Because if you know how to add, you know how to subtract. It's the same thing. So we have this concept of, let's do 13. Right? Easy, right? You know, it's not a separate, so what I'm trying to say is, it's not a separate strategy when you add and subtract. It's just the opposite. Just like how negative is the opposite of positive, division is the opposite of multiplication. Same thing, and that's how the abacus works it. The abacus works it, and so you don't need to have a whole new strategy. You just need to know your signs, right? You just need to know your operations. If you need to add or you need to subtract. But again, realize, in order to add, we have to subtract. In order to subtract, we need to add. Just like drifting.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
Thank you so much. Let's do a celebration. There's a celebration. Na 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 na. Thank you so much. Let's go. Right. Thank you so much. Thank you. Oh, maybe this one's better. I like this one. I like these ones. I think these ones way better. Ole! Thank you. All right. So, thank you, 300. Love you so much too. You guys are awesome. Oppa. Sorry. Okay. So, this is crazy. This is going to be good. All right. How are we going to do? At least I get something. Okay. We're going to continue on. Okay. Guess what? Okay. We know this, right? We know this. Now, this is the concept I was really kind of interested in showing you. Nope. Where is it? Here it is. Okay, so in mainstream, we have there's these things that they teach the kids. They have to memorize like these number bonds, like presets of fact family of 9. Okay, almost done. Okay, I don't know if you guys know your fact family of 9. Here we go. This one? Okay, we'll just do this one. Right. So, mainstream, what do they do? Not that one. Here we go. So mainstream, what happens? They have to borrow, right? They got to borrow, so they got to take away the 10 from here. This becomes 1 because you take away, and then this becomes 13. Then what happens is you have to memorize that 13, and you have to memorize that 4 plus 9 is equal to 13. So this is a fact family of 9 that they have to tell the kids that they have to memorize, which is fine. It is up to you if you want to. But in Abacus World, we don't need to. We have to pay attention to this number. This number is what's going to help us. Why? Because all we got to do is understand that we have to just minus the 9 equals to minus the 10 plus the 1. That is all that we have to memorize. So even if I take, okay, so I take away the 1 from here, and then I take away the 9. Take away the 9 is what? Minus the 10 plus the 1. So my final answer is 4. All right, that's 1. All right, let's keep going. We're going to continue on, and I'm going to show you that you have to memorize another set. How is this going to work? Well, it's the same thing. You cross this out, make this a 2, and then make this a 15. So we know that 15 and 9. 15 and 9 is what? You need to memorize 9 plus 6 is equal to 15. You could do that. You can memorize this. You can memorize that 9 and 4 is 13. 9 and 6 is 15. You need to memorize this. What up? What up, Dougie? So what are we going to do? Here is what we're going to pay attention to. We have 35 on the abacus, right? We have 35 on the abacus. When we're looking at it, we want to take away 20. We take away 20. We want to take away the 9. When you take away the 9, is there enough? No, there's not enough. What do? You have to, all you got to do is memorize minus the 9 is equal to minus the 10 plus the 1. So all you got to do is minus the 10 plus the 1. So my final answer is 6. Are you using LCM, lowest common multiple? No, I'm not. I'm using complements. Complements of numbers. That's all I'm using. So I'm using 9. We know how to make a 9 and 1 is equal to 10. That's what I'm doing. I'm using complements of numbers. Complementary numbers. That's what I'm using. That's what they're called. Complementary numbers. Got it. Okay, see you later, Jess. Have a great night. You too. You too. Keep working on the art. I'm so proud of you. Right? Okay, what part did we get lost at? If we know how to add, we know how to subtract. If we don't... Yeah, we know how to add, we know how to subtract. Thank you again for the rose, Jess. Wait. Let me do this without you. Okay, you tell me. So let's do this one, right? Let's do this one. Oh, you got it after the second example? Yeah, Jess. Okay, Elle, let me know. I got it after the second. Right, that's what I'm saying. Crazy, right? Simple. Super simple. You know it, it's so scalable. It's fantastic. Okay, cross out the 8. Yes, cross out the 8. And, oh, yes, that's right. Make it 16. No, yeah, cross out the 8. Right, this becomes 7. Yes. Oh. Oh, I know what I'm doing wrong. I need to cross that out. This is what we do this is what happens in mainstream, right? Mainstream, you need to memorize. This is what you do in mainstream. We don't do this in Abacus World. Mainstream, I'm just showing you an illustration. In mainstream, you need to memorize that 7 and 9 gives you 16. You have to memorize this. But in Abacus World, we don't do it. Yeah, the Abacus World, we don't do it. I'm sorry, I forgot. I keep forgetting. Abacus World, we don't do it. Here we go. In Abacus World, we take it like this, right? We have 86. Okay? And then we look. We just take away the 5. Can you take away the 5? Yes, take away the 5. Okay? Make sense? Now we're taking away the 9. We take away the 9 from the 6. That's all we're doing. That's all we're doing. So how do you take away 9? Take away 9 is what? Oh my god, I feel like that guy from Big Trouble Little China. the lightning guy. Here we go. Bills. Take away. Right, because we're just subtracting. So all we're doing is we're taking away the 9. 9 and 4. No, not 9 and 4. You cannot take away 9 and 4 from 6. There's not enough beads to take away 6. There's not enough beads to take away 9. You gotta borrow from here. You gotta borrow from here, right? That's why we get this. Minus the 9 is equal to minus the 10 plus the 1, right? Minus the 10 plus the 1. So when we're looking, right, all we gotta do is minus the 10 plus the 1. So, thank you so much, staff lawyers. Thank you so much. I appreciate that. Okay, sorry. I went too fast. I apologize. I went too fast. Let's go back. Because I was just so excited that you don't have to... Okay, here, the reason why I'm so excited, right, is because you don't need to memorize. You don't need to memorize 9 plus 4 is equal to 13. You don't need to memorize 9 plus 6 is equal to 15. You don't need to memorize that 9 plus 7, right, and is 16. You don't need to memorize all of this stuff. You only need to know and understand this concept, how to take away the 10. That's it. Big Trouble Little China reference from the Mortal Kombat games. Oh, yeah. Is that... Yeah. You move back the 10s, so it's 9s. Yes, exactly. I'm starting Algebra 2 this year. Do you have any recommendations? I don't, Brandon, but I will send you to somebody who will. If you want to DM me, I can send you to Audrey. Audrey does algebra. I don't do algebra. I just do a basic arithmetic. That's all I do. I just do Abacus. That's all I do. Okay. We're taking away the 10 from the Abacus. Yeah. So, should I take it? Let me take it one step back. Let me go back to adding of the 9. Right? I know I went too fast. Audrey is the queen of algebra. Yes. Audrey is the queen of algebra. Okay, let's go back. So we know how to do the 9, right? Here we go. We have 9 on the abacus. 9, right? So it's minus the... Yes, Reaper. It's minus the 10 plus the 1. Because yes. So for us, you know how to add. You'll know how to subtract. Yes. So it's minus the 10 plus the 1. When we're doing it, that's what it is. When we take away the 9, this is the formula you need to know. This is the formula because why? We want to take away the 9. So you know that 9 and 1 makes a 10. So if 9 and 1 makes a 10, see, it's a different way of thinking. It's a different way of thinking, but it's a little bit more efficient. It's a different way of thinking, but it's more efficient because you don't need to memorize all these things. You just need to understand how to take away the 9. You only need to understand how to take away the 9. You don't need to worry about all of these little other things that you have to memorize. Yeah? Do you see it?
This is the way.
This is the way.
This is the way.
Going backwards is minus, and yes. Going backwards is minus, right? Going forward, right? You add, you carry over, or you borrow. So in Abacus world, we don't say borrowing and carrying. What we say is you add the 10 or you subtract the 10. So in Abacus world, you add the 10 or you subtract the 10. So I have 9. I want to add the 10 minus the 1. If I want to subtract, I have 18. 1, 8. If I want to subtract the 9. I want to minus the 10 and add the 1. So if you know how to add, you know how to subtract. Right? Obviously, my books are a little bit slower. We're here, and I'm just kind of rushing everything. But like if you're looking for materials, I do have an abacus for adults available in my TikTok shop. I will pin it. And what I do in this book is I walk you through all the activities, right? So you understand how to make a file. The first thing you do is you understand how to read the abacus. Hold on. Right? You learn how to read the abacus. You go to the double digit, triple digit, quadruple digit, the 4 digits. I give you the mask maze, and then we start going into adding and subtracting. We go adding and simple subtracting. I give you some examples, right? And then after that, I give you pixel art. The idea with this pixel art is making sure that you follow the path. The reason why is because I want you to see what it would look like to add the 2. So 2 plus 2. I want you to just see that. I know you could do it in your head, but the idea is to be able to move the beads and see the beads move. So we go through that, and then this is where we start talking about the plus 5. We talked a little bit about the plus 5. I give you some equations, and we talk about the minus 5. After the minus 5, I give you an activity called the hidden words, and then here is a summary of all the 5s. Right? If you know how to add the 5, you know how to subtract the 5. Then we go into the 10s. That's what I did with you right now. We talked about how to add the 10. Adding at the 10, and then I give you an example. I give you some activities. After do the activities, then I give you this thing called repeated addition. Repeated addition is what we do in the abacus world and how to do multiplication. So after we do multiplication and you do the word ladder, right? And I try to mix in some like activities for you to learn. Then we do the minus. That's where we're at right now. You learn how to minus the 10, right? And then I give you some examples, a review about making the 10, color by number. They give you some room to write the formulas. You make your own color key, and then we do a word ladder. Again, these questions are very specific to borrowing or to minus the 10. This is the summary of making of the 10. We made a 10, we subtract the 10. And then this is the workflow. There's a workflow when we're looking at how to look at the numbers. When we want to look at it, there's a path, there's a workflow. If I want to do 7 plus 4, this 4 is what we're in questioning. Do you have enough beads? Yes or no? Can you use a 5? Yes or no? Then if no, then you use this, right? So there's a workflow in Abacus, and you go through it over and over again, and that's why it's a puzzle. And that's what we're talking about. It's a puzzle because you get the little individual elements, but you have to figure out how the puzzles fit. So this is what I call a two-step equation. This is my own terminology, a two-step equation. The reason why is because you take adding of the 10 and adding of the 5 to the next level, or you do adding of the 10 and you do it twice. That takes it to the next level. And then I give you activities. You answer the question, and then you find the puzzle piece, cut it out, and then try to figure out what the puzzle looks like. I give you room to write the formula, and this is more equations. Again, we talk about reviewing the multiplication. In Abacus world, we only go from 9 times 9 table. We don't go anything above that because anything above that is redundant, and we do distributive property. So then we do minus the two-step. After you do minus the two-step, here's the puzzle, here's more equations, find the answer, and then figure out the puzzle. And then you have your mosaic, your mazes, your hidden words, and more word ladder. And this is my book. And so what I do is I walk you through it step by step on how to do adding and subtracting on the abacus. And if you're ever wondering, I do have the answers in the back of the book. And that's it. You have the option to buy an abacus, either the 7-column abacus or the 13-column abacus, or no abacus at all. But I do recommend, if you don't buy an abacus from me, I do recommend that you purchase an abacus from somewhere. Just because physically seeing the abacus makes it so much easier to do your numbers. It makes it so much easier than trying to abstract the symbols of and that's what we're trying to get through, right? So the difference is symbolically, these are still symbols. They're not real. They don't mean anything. So it's very difficult for our human brains to understand what this is. That's why if you see something concrete, it's easier to move. And it's still very different even if I drew it out for you. you still don't get that same set of understanding because you don't move the drawings. Moving the beads really help this context. I need a little more practice than I love math. This new is to me. Yes. Yes, I believe it's new to a lot of people. I am here to introduce Abacus to the Matrix. That's what I am here to do. Welcome.
Welcome to the real world.
It is good for consent and visual learners. Yes, you know what? Yes, I do so. Yes, I believe so. And I believe it's very good for just getting to understand a different way of thinking, and it just kind of works your brain a little bit. So it's more like, it's so interesting. It's exactly what it is. It's brain gymnastics, like we do with Sudoku. What else? Sudoku, crossword puzzles, word searches, and all the other logical puzzles you do. Even with the video games, right? Even with the video games, when they're puzzle-like, they're my favorite. But W with the T. Thank you. I know, right? People are watching math in the middle of the night. It's so crazy. And I was just telling you that. I was just like talking about it. I was like, that's crazy. It's like 90 people in my room talking about math. Thank you. But it's interesting that so there's that James Clear person, right? He's a writer. And he talks about the atomic habits. And one of the habits is make it very incremental, that you keep doing it. So like I started putting sunblock on my face. And then before I go out for a jog or whatever, right? I have to remember to put sunblock because of like skin cancer or whatever, right? So we got to protect our skin. So what did I do? I ended up putting my sunblock in front of the door so I can remember to put it on. And I'm like, that's brilliant. And it's the same thing with Abacus. Abacus is not anything. It's just showing you the stupid numbers. It's just showing you numbers. But you know what? Because you can see the numbers, because the numbers is a representation, you know what to do with it. And that's what's amazing. It's so amazing that it just tells you that this is 9. And wait, I don't have enough room to add another 1. What am I going to do? Then you have to go through this concepts of, okay, can I add a 10 or can I add a 5? You know what I mean? You have all these like things in your head that just kind of like, oh, I have these things. But it doesn't complicate the memorization of everything. You don't need to memorize everything. Hello, Fragile. Hello, Fragile. How are you? How are you today? You know what I mean? And so that's the difference. And so that's what I was trying to show you here, where in mainstream, you have to memorize what they call the 9 fact family. This is not a 9 fact family, right? But they tell you that you have to memorize it. But in Abacus world, you don't need to. You just need to know this. And it's the same thing with like, and then don't forget, this is only 9. There's a fact family of 8. You got to know all your 8s. I'm like, what? What's my 8? Minus 8 is equal to minus the 10 plus the 2. That's all I want to remember. Right? That's all I want to remember. I don't want to remember everything. I want to remember what I need to remember. These are the only things you need to remember. 7. What's 7? Minus the 7 is equal to minus the 10 plus the 3. That's it. That's it. All I did. She understood the abacus. Oh, I'm sorry. I had a classmate who couldn't do math on paper, but she understood the abacus when the teacher, oh yeah, showed her? Oh yeah. Yeah. Cause paper is still abstract. You know what I mean? We do all these things. Even like we do all these things. It's still on paper, right? Yeah. Like even with the number bonds, it's still paper. It's not a physical thing. That's why it's different when you do it on an abacus. Whether it's a colorful abacus or whether it's a colorful abacus or a single color, excuse me. Whether it's a colorful abacus or a single or multicolored abacus, it doesn't matter. It's the concept of the beads. That's really what it is. It's just the concept of the beads. All right. How are we doing? I'm about spent. Yeah, so all my books are in the TikTok shop. It is available for it's only adding, subtracting right now. I'm still building out my books for multiplication, and I do plan to have like a whole multiplication line. But for right now, I don't have it. It's just understanding the basics. I hope you're not feeling. It's allergies. That's what it is. It's allergies. I have to wait for the Santa Ana winds to calm down. But yeah, but thank you. I do appreciate it. But that's as much as I got. I am gonna tap out. But I'm excited that Ellie lived, right? And Reaper and and there's a bunch of others. Yeah, it makes sense, right? Yeah, like Huey and Eric and Dude won. Thank you so much for that. Yes, the little Big China, Big Trouble in Little China reference. Thank you. God Raiden, that's what it is. Hello Mars. Hello Mars. Thank you so much. I appreciate you showing me and learning something new today. Oh yeah, you're welcome. You're welcome. You're welcome. It's my pleasure. It's satisfying to be able to teach somebody who's willing to learn something different. You know what I mean? To learn something different. Luffy? What's Luffy? I know it's something different. Is it useful? It is useful for adults if you have the time. If you want some time for a hobby, it is very good. I do have thank you so much Mars for the checking in. For those of you that are interested, go ahead and check in wherever my fuzzy hat is. I'll get an happy soon. I'll update you. Okay, Ellie. I just ordered my third shipment of Abacus. So that's how the crazy one from One Piece. Oh, I don't know. I don't know One Piece with the hat. Oh, I don't know One Piece. Yeah. No. There we go. I don't know. I kind of briefly know about One Piece, but I didn't really pay attention to it. I tried watching. It was hard. It was difficult to watch. I do like AOT. I do like AOT. That one was, oh my gosh. Oh, I've been practicing. I'm gonna get into it. Okay, great. Yeah, if you like puzzles, if you want to have a hobby, and that's what a lot of the adults that have been coming to my live, those that they don't have children and they just want to have a hobby and they just want to keep their brain active, and that's what they're doing. And so I have my adults for Abacus for adults, but I do have a few adults that actually purchased all of my books. So the books, if the adult Abacus for adult is too fast for you because it is a summary, you might want to take it slower. You could do the plus the 5, minus the 5, plus the 10, minus the 10. So it's up to you. I have the separate mazes, the 2-digit, 3-digit, and 4-digit. And then I'm starting with the Halloween one. So there's a Halloween one that I'll be promoting pretty soon. And then there's a Christmas one as well. But this one's more for like, I was thinking it was going to be young kids, but then I'm going to make an adult version one as well. But that won't be until later. I'm still working on my other book, and then from there, continuing on with my curriculum, because I want to be able to actually expand it to everybody who's in second grade. Will be able to utilize these set of books, and then have another set for third grade and fourth grade. Oh, thank you. Yeah, these are all my books. I've created all of these. These are mine. My name is Lynette. I've been teaching Abacus for about 20 years. Yeah. And so I just now stopped. I finally realized that I should stop gatekeeping and just try to instruct or teach as many people as who are willing to learn and to keep your brain active, because we want to offset Alzheimer's. Right? So that's the whole point. And that's what they say to, like, be able to keep your mind active. Just like they say, you should learn how to play an instrument. You should learn how to play an instrument to keep your brain active. I am here to say you should learn Abacus to keep your brain active. because numbers can get very interesting. And I'm here to also make sure that I do. So this is my name, and this is my whole collection. You can buy it there, but I don't sell the abacus there. You can buy your abacus here, or you can buy it from somewhere else. But I don't sell an abacus here. I don't sell the abacus here. I sell the abacus on TikTok Shop. That's the one caveat. I couldn't figure out how to do it would cost too much to do shipment from here. So that's why I did it with the TikTok Shop. Yeah. If you buy it here, and you buy like I think more than 30, I think you get free shipping. So it's up to you. Yep. Cool. Does anybody else have any other questions before I sign off? Thank you everybody for joining. Thank you everybody for joining. I do appreciate your attendance and your interest. I can't believe there's still 100 people in this room. I'm so flabbergasted. Flabbergasted. Yes, not a problem. Yes, Ellie. What's up? Yeah. Yes. Oh, for the 13 column, is it the same? Ah, interesting. For the 13 column, okay, so there's two ways of looking at it. Yes, they are the same. The only thing that's different is that the abacus, the 13 column abacus is just bigger. Because you might need a bigger the bigger the abacus, the more numbers, right? Because size matters. So when we're looking at it, you might want to do the multicolor one because it's cute, you can carry it everywhere, and it's easier on the eyes. If it's too overwhelming, the 13 column abacus is fine too. And you can do exactly the same with the 13 column abacus. It's just, when we do the one, you're just going to have extra stuff, which is fine. And then if you look, there's the dots, there's the labels. We have our ones, our thousands, our millions, billions, and trillions. So you could choose any one of these dots to be your home. So if I choose this one to be my one, you could choose this one. So then you'd be your ones, your thousands, and then your millions. And then you have all of this to be your decimals. Whereas the 7 column one is a little bit more restricted because it's a little bit short, right? So it is up to you. If you don't want to have too much clutter, then I would say go with a 13 column abacus because you go straight into it. The reason why I would use a 13 column abacus is for division. Division, you need the extra columns to help you. You just need some extra columns to help you with the placement. Whereas on the 7 column abacus, it's a little bit more constricted. It is a little bit difficult to move around when you do division on the 7 column abacus. You can do. If you're with my books, you can do everything up to multiplication with the 7 column abacus. But I noticed that I find I get into I get into situations where I cannot do my division on my abacus. So I would always change to the brown one. So it is up to you. There's a lot of adults that actually purchase the 7 column one, and then they want to graduate to the 13 column one. So you could do that too. Sometimes it's nice to be able to change it up, but I do know that if you don't need that many and you don't want to have clutter, the 13 column abacus would be just fine. I actually learned off of a abacus similar to it. Back in the day, about 20 years ago, the only abacus that was around was these ones, not division. No, not today. So this one is my personal one that I actually worked with when I started learning abacus. This is a hold on. This is a 23 column abacus. So it is, considerably a lot larger than the others. And the beads are smaller. This one is also made out of bamboo. I don't sell it, but if you notice, it's smaller than the others. So, notice that the beads are smaller. Yeah. So, and it's a little bit quieter. Whereas this is made out of bamboo, these are made out of plastic, and that's the difference. Yeah. But back in the day, we didn't have a lot of selections. So it is up to you. I worked with this one for quite some time. So it's your own preference. Yeah, I've been teaching Abacus for about 20 years, and this was all that was available. This one is made out of... This one specifically is Japanese made. This one, I believe, is Chinese made. Maybe it's Japanese. I don't know. Oh, excuse me. But I know my shipment is coming from China. And, yeah, and see, you'll see there's the dots. We still have dots. So it doesn't matter which dot you choose, because these dots are the groupings of the columns. Like the thousands, the millions, and the millions and the billions, right? So when we're looking, that's what the dots are very helpful to help label. All right. So I hope that was okay. I do appreciate everybody being here. I can't believe, right, Fragile? Look how many people there is. When it was before, it was only going to be like you, me, and somebody else. Hello, Jason. Now it's like crazy. All these people wanting to talk about math in the middle of the night. Who would have thunk it? Who would have thunk? Who would have thunk that there's so many people that want to talk about it? Just lurkers? Yeah. But you know what? There's more lurkers. When we go live again, probably tomorrow morning at about 6. If I can go to bed early, if I can go to bed now, I'll probably try to get about 6 or 7 in the morning. So that's like Pacific Standard Time. Because right now it's 11:40 for me. If not, it will be tomorrow night at 9 p.m. Pacific Standard Time. Your voice is calming. Oh, thank you, Laura. Thank you. Not really 80 wanting to learn this late. My brain is satisfied for the night. Oh, good. Oh, good. I hope you sleep well. I hope you sleep well. Thank you, Laura. I do appreciate that. And math is fun. Math is fun. There's nothing... just take it one step at a time. I know I gave you a lot of information. But see, that's the thing is like, that's all there is. You're going to start seeing that there's number patterns. And the funny thing is the Abacus will show you the number patterns. And you're going to see it. You're going to see the patterns, but you move the beads enough. It's up to you if you want to go mental math. I don't. I still use my Abacus. I still like it. I like the feel of it. I like being able to move it with my hands. I like the kinesthetic on it. So when we're looking, so I still will take out my Abacus when I have to do stuff. Yeah. So... thank you everybody for joining. Thank you everybody for joining. Even the lurkers. I would never have this many lurkers before. Right, Fragile? I would never have this many lurkers before. So, but I do appreciate everybody here and spending some time. I mean, it's crazy that you guys are all here. But thank you. No, even the lurkers, they're spending time. No, I'm here to learn. Okay, Joel. And it's still going up. I know, crazy, right? It's amazing. But I do need to shut it down, though. Shut it down! Oh, no, that's a comedian. There's a comedian I really like. His name is, he's a white guy named Bob Marley, and he's from Maine. He's really, really old now, but he's so funny. I love comedians. Have a good night, Joel. Thank you so much. You need it. Oh, thank you so much, Al. Thank you so much. 24 before getting off that, what night? What a night. I know, right? Crazy. Like before, I would not even hit like 5,000. Like it was a struggle. It was a struggle. But I think what I need to do is I need to start bringing some like tapping sprees. You know what I mean? Like this. Oh, I can do a tapping spree. So let's do a little tap out. Where are we? Oh, here it is. A little tap out before we leave. If you could just help me out and do a little tap out before we leave, I would really appreciate it. I don't know. I gotta start bringing in more tapping out because somebody mentioned that they cannot tap and learn at the same time. So I gotta give like a little break. And so, that was the one thing is like, okay, if I give you this number, while you guys are tapping, what number do you think this is? There we go. What number do you guys think this is? And then I can put in some music. This one. I like this one. Ah, there we go. So, yes, thank you. No, Deuce, it is not. It is not 5,000. It is 9,000, 95,000. When we're looking, we want to do 95,000. So we have 9 right here. 5 plus 4, 1, 2, 3, 4. 5 plus 4 is 9. And then we have 5. There's a comma here because I have a label. That label tells me, right? That label tells me the thousands. And then we have the 2 over here. So that's a 2. There's a 3. 1, 2, 3. And then we do 2 again. The 2 is right here. Because this is the ones place, this ones place tells me that this will be my decimals. My decimal sits right here, so this would be a 7 and a 0. There you go. Thank you, Simple Tofu. Yes, it is 95,232.7. Yep. Yep. Well done. All right. Thank you everybody so much for joining. Thank you everybody for joining. I am going to sign off and have a good night. If not, I will see you all in my next live. And
Good morning.
Morning.
Good morning.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
good afternoon, good evening, and good night. See you guys, everybody. See you all in my next live. Bye, everybody. Thank you for the hearts. Thank you for the follow.